Good morning and good evening, everyone. So, welcome for our third session, and I am hoping that everyone has started typing in Python code. They are already installed Visual Studio Code in Python already. As I mentioned last time, that we will be doing more coding and less talking. The reason I'm saying I will be the next session, not today. I wanted to do it today, to be honest. I was so excited. I wanted to do a game today from today, but after discussing and checking the things that we need for that game, uh, I thought to, first go over those things today so that we can work on that game the next week. So it is very important that you have that environment installed, Visual Studio Code, Python installed, the extension installed. If not already, go to watch session number one. I described how you can do that on your laptop, on your machine. And if you have any issues, please reach out. And today's session is very important because I will be discussing how um, you do all those things you will be referencing all those things in in the future. So it is important that you understand those. So let me share my screen and start. Okay, which screen it is sharing? No, it is sharing the Zoom screen. So many screens are open. I need to share this one. Okay, can you see the slides now? Okay, it will be very helpful if you guys speak up. That's how I know that you guys are hearing, and it's nothing to be afraid of. We are we are just a small group here. So it's just us. So please speak up.
Okay.
Okay. Anyone else can speak, please ask questions. Can you guys see my screen other than Misha? You can type as well. I can see that. Okay, so today is Python session number 3. And those who joined today, you can see I have 19 years experience and I'm a technical consultant. I did my engineering from Karachi, Pakistan, and now I live in Cincinnati, Ohio. So just a quick thing for those who already know. So, and those who didn't, I just put it there. I will reiterate the our objectives here. I will do it every session so we know what our objective for the session is. Learn the basic principles of programming. And then we will apply those principles in Python. You can apply those principles any language, but here in this whole session series, we'll apply those principles in Python. And in the whole process, we'll learn about Python pre-built capabilities, and we will develop, few games so we can learn more about Python and its capabilities. And towards the end of this whole session series, we'll do a project. That could be anything. It could be a game. It could be any project of your choice. But that will be one of the most interesting thing because I love to see that uh, in the end. Today's agenda, just like last time, I'll go a quick recap what we did in last 2 sessions because it's very important that we keep on retaining what we have been learning in the previous sessions because we have to build up. If we forget what we learned last few sessions, the next sessions will become meaningless. You'll forget what we learned. It will be very challenging going forward. So it's important that you revise, and I'll go a recap too, so we can revise in sessions as well. We have been reading about computer programming, and then we talk about what is a computer program, and today we'll discuss why we program, right? And then we'll quickly talk about the components of computer program, and then we'll write each component, uh, programming component. So that's why I was referring to earlier that we will dive into writing programs more often now than just talking. And then it will become more interesting because you are here to do programming more than listening to me. Okay, so let's back to our recap session. Session one, if you remember, if you don't, but you should remember now that we discussed in session one that computer programming is a way to communicate to computer. Computer understand only machine languages that are zeros and ones. To make it easier for humans and scientists, engineers develop low-level and high-level languages such as assembly and Python. Python is a general-purpose, platform-independent programming language. And by platform-independent means it can run on Apple machine, it can run on Intel machine, like Apple, you have MacBook, or I have some other Windows-based software. In session one, we install Python 3.12 version. I mean, this is the version 3.12.6 from python.org. Please, if you haven't, go to the site and download it. Watch session number one to install it. Then we install Visual Studio Code, which is a free software. It's like programming environment where you actually type the code for any language, and we learn how to type the code for Python. You can download it from code.visualstudio.com. After installing Visual Studio Code, we installed Python extension on top of it, and then we wrote our first Hello World program in session one. Please rewatch session one if you haven't, especially if you want to do the installation piece. Then in session two, we talked about what is computer program, which is actually a set of instructions, multiple instructions, and you group them together to perform a single task. And we created an instruction set for fetching water. If you recall, we wrote instructions for a person to, get up from sofa, walk towards the fridge, grab a bottle, fill it up, press the button and fill it up until the bottle's full, and then pick it up and move, turn around, walk back to the person, hand over the bottle, and then go back and sit again. So we created that instruction set and we call that fetch water. And that instruction set, we called it a program. Then we discussed about variable. What is a variable? Simply way to keep track of information. Just like a name tag. People wear name tags to identify who they are. And then we discussed that in programming languages, we use these tags to store information inside computer memory. And we gave an example like just like in games, you have a score and you save that information inside computer memory. Then we also discussed what's the difference between data and information. Data is simply any raw numbers, characters, or string of characters stored in computer memory. That doesn't mean anything, right? For example, like if I store 42, I gave this example, that's why I'm using the same. If I store 42 inside computer memory, it's data. It doesn't mean anything. It's just a simple number. But if I say my age is 42, then it becomes an information, right? It means something. You can understand what now 42 means something. So that's the difference between data and information. The reason I told you this difference because computer needs to know what information you're going to store inside a variable. So that's why we discuss data types, that when you are defining variable and asking computer to hold this information inside this variable, you need to know what information you're going to hold inside that variable. And that's where the data type comes into play, that you have to tell computer what type of data you're going to store in that variable. So when we discussed like three data types, for now that numbers, characters, or string of characters. When I say string of characters, like multiple characters together. So for his computer to understand numbers, you just define numbers without anything, just numbers. If it needs to be a string of characters, it has to be inside, two quotations. All right, and in the end, we did labs where we added two numbers, and then we added two numbers based on user input. I pasted the code in the chat, and I hope that you guys tried on your end. If not, please do it. It should be in the chat still. Please do try that code. Just simply retype it. Try changing something. Maybe try changing the name of the variable I use. Try changing some operations that I did. Okay, so today's session. Why we why computer program? Why we have to do programming at all? Any idea? Anything? Like we are talking about computer programming. We talked about what it is. We talked all those things in previous two sessions. But do you think why we are doing it?
So we can like tell a computer what to do,
But
or
why? Why we are telling computer something to do? Why we want some dumb device to do something for us?
to make life easier.
To make life easier. That's good. Yes, to make life easier. And if I break it down further, to make difficult tasks easier, like complex calculation, just like calculator, you want to divide like uh 57 by 3. You can do it, but it will take time. So easier by doing complex calculation faster. So that's why you use computer or calculator. So in a way, computer is is a calculator. But calculator is a computer, but you cannot do a lot of other things with any other thing. Anyone else? And by the anyone else? Another thing we ask computer to do is, which humans can get bored, is to do repetitive tasks. If I ask you to do, hey, can you write these lines 100 times? I'm not sure about you, but when I was younger, sometimes at school, if you're late at school, the teacher would say, write 100 times that I will not be late tomorrow. So, those sort of things, they become boring for a human. So, there are times when you have to do something many times. So the tasks become, you have to wait, you have to do again and again. Those tasks become repetitive. So you can ask computer to do it for you. It's just a machine. Just- if you recall our instruction set from last week, we have to ask computer or someone to press the button of the fridge and wait until the water bottle is filled up with the water. So it's like repeat the same step of pressing the button or keep on pressing it or wait. It's a repetitive task basically. So we need computer to program a computer to do repetitive tasks. We ask computer to program to make difficult tasks easier. Then to act as a smart device that can make decisions for us, right? Sometimes there are situations when computer needs to take decisions for us. Just like, for example, if you are asking, let's say you are going to market to buy something. Your mom or your dad sends you to a market or to a bakery or to a shop to buy bread of, let's say, ABC company, like say buy bread of this company or this brand. So you go and you did not find that brand, right? But there's brand of other companies. You can buy that brand, right? So that's a decision making there. So your dad or your mom can either say that, hey, go to that shop, buy the bread. If you find brand A, buy brand A bread. If you find brand B, buy brand B bread, right? So when you go to the shop, you find brand A, you will find the brand A bread. If you don't find brand B, you don't, you buy the brand B bread. And now you are human. You, if you don't even find brand B bread, you might do some other decision. But for a computer, you even have to tell if what if you don't find brand B at all, then you have to tell that as well. So you have to uh, make computer tell the computer when you have to make smart decisions. So that's when you program as well. See, so make tasks easier, repetitive tasks, and make decisions. These are the things of computer programming or computer program. And sometimes you have to reuse something. You don't have to tell it again and again. So that's when you program. So for example, last time when we told some uh, person to get up and wrote all those instructions to get up and walk how many steps and grab this bottle, move your hand, and then walk further, and then press this button. And we wrote so many instructions, right? And then asked to do this and do that. So next time we have to uh, like ask the same thing. We don't have to tell them the same instruction again and again. We just ask, hey, can you fetch the water? We simply reuse that instruction set, right? So within computer program, there are tasks of that nature as well that can be same in nature. Like you're adding numbers again and again and again. So every time you add, you simply say add or maybe print. You notice that we print a lot. So when you do print, there could be multiple instructions running behind. But you notice I only say print. So there could be some further instructions that are grouped together and I only say print. So that sort of reusability that become part of computer program. And don't worry if it's not making sense. Now we'll see it. That's why we are here to learn all those components.
Uh, mobile phone. Small choco.
Hello?
Red shine yellow. Small.
Okay, sorry. I couldn't hear if they were talking to us or anyways. So far, so if you notice, and I'm sure you must all have studied science so far. Any anything comes into your mind what a computer is after reading all this? When I read all this, I remember my science from grade 7 or 6. I gave you a hint. What a computer is. You start with a letter M. Any clue?
Computer
Okay.
is a machine.
Yeah. Computer is actually a smart machine. Perfect. Perfect. The computer is actually a smart machine or simply machine. So all these are the components of computer program, and that makes computer a machine because it makes your life easier. It takes your input, and your input is less, and your output is more, and that's what the computer makes a machine. Okay, so we will go to our next slide here, and we will continue basically these components and look what they are in computer programming languages. And most of these languages have the same keywords, or what they are actually they're called the same. There could be some different ways of expressing it, but they're called the same. So let's see what it is. So making tasks easier, you perform calculation by, like operators like plus, minus, division, uh, multiplication, and then you can when right now you probably haven't read all that complex mathematics concepts, but then you can add all those calculations to factorial and then series of you'll study later, but all that tasks you can perform inside making tasks easier where you can create all those mathematical calculations. The repetitive tasks you can do it through loops, right? That is number that thing that you where you have to do something repetitively. In computer language, generically it's called loops. That's something that runs within a loop. Decision making is based, and then reuse decision making is, is based on some condition, and I think it's on the next slide. I'll show you the next slide. So the the repetitive task is in most of the language is either controlled with called loops, is either with for loops or while loops. And I'll tell you what it is. Same with Python. There is a loops are either for loops or while loops when you need to repeat something. The decision making is added into your program with a keyword called if, and then you provide condition that if this happens, do this. If this happens, do that. Just like the bread example I gave you. That if you find this bread, buy this. If you find that bread, buy this. Reuse we call in programming language functions, and there are many definitions of functions right now. For simplicity's sake, you just remember they're called functions. Um, when you grow further, you progress further, there's a better definition for functions. Right now, you just understand that functions we write in programming languages to when you know that you have to do something again and again and again. So rather than writing that code again and again, you write it once and you call it from somewhere, or you reuse it again and again. And you will understand more when we actually use it. So don't worry about it. Okay. So like I said, we will be doing more work than talk. So we are here in our lab so quickly than we did the last time. So today we'll be doing for loop, while loop, if condition, and another concept that we haven't touched yet, but it is very important, especially when we will be talking about functions, is indentation. It's very important in Python, and you'll know why. And then we'll discuss about the functions. So let's get back to our Python environment, which is Visual Studio Code. And if you want to do like, if you want to do along with me, please follow along. That will be helpful. So I open up my Visual Studio Code, new text file. I'm gonna select the language here, which is Python. Okay. And the first thing I do always is save. And when I save, this lab is for loop. Session 3, Python, session 3 for loop. And if you remember last time I told you how you can comment, so I'm gonna start with that. Okay, this is comment. This line is not read by a computer in a Python, so that it will not error out. All right, so today's and last time what we learned, how you could do variable. You guys remember variable? So to type a for loop, so first I will say what our objective here is for loop. For loops are used to do some task or certain number of times. For example, counting or for loops in for loops to type some number from 1 to 10, right? So you know how many times you have to perform something, or you know how many times you have to do something. So for example, you say, and it start with the word for, I, I is like in computer programming, we call it iterate, means number of time you need to do something. It's I is a variable. So you can say it's a variable, right? So for I in range 4, and then you type it, and then you happens. What it did, it printed number from 0 to 3. And if you notice that a lot of programming languages, their counting is start from uh, 0. And you will understand later like why that advanced concept, and you will understand, you know, when we go further. So remember the keyword, it is for, and we use it for when we know the number of times when we have to do something. Any question here? We want to try it. Okay, so we will be moving to our next example, and that will be while loop. And while loop is something which is basically a situation you how many times you have to do something. This is like, for example, this is, so the number 10. Let's see what it does like this. See? Now say 1 to 10, so it's starting from 1. Okay? So range, you use for loop. And now, if you don't know that how many times something needs to run or something needs to repeat. For example, when we were filling water in the bottle, we don't know how many times we have to press the button. So we had a condition over there that keep on filling the water until the water is full. So that's a condition. You did not tell the, hey, fill the water from 1 to 10, right? So that sort of loop is called while loop. And we can save this and we can create a new file, keep it completely separate. We could have done, same file, but now we have created separate, so we will do separate. Okay, session 3 while loop. And I can copy paste this so we can save some time. Don't have to type this. While loop. While loops are used to do certain tasks until some condition is not met or happen. Any question here? For example, fill the water in the bottle until it's full. Okay, so this is when you use while loop rather than for loop. You know when, how many times. So we have a variable here, number equal to 1. And now we need to say while number less than equal to 3, print number. And number equal to number plus 1. Now if you notice, first I did the variable, and you know what a variable is. Assigned a value into it. So this line is creating some place in computer memory and gave us a tag, and we call it this tag a variable number, and it saves some value 1 inside it. And now we're asking computer to while the value of this number is less than or equal to 3. Print it on the screen. Print whatever value is in, print it. And as soon as it prints on screen, the next instruction we are giving it, we are giving it this instruction. This is a mathematical operation here. See that inside this value, what we are assigning now, whatever the number here, which is 1 at this point, plus 1. So when it is first time it runs, it come up here while, and this is a loop, means it will keep on running, 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 running. It won't go here, right? So loop means something will keep on running, 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 running. Okay, so first time, remember, program runs in sequence. So run it like a computer would. It will come up here, it will store 1 in the computer memory. Then it will come up here. It's a while number is less than 3. Print number. So number right now is 1. So this condition is met. It is less than or equal to 3. So it will print the number. Then it will come in this line. It will add 1 into number, which is 1. So the value will become 2. Then we'll go here again because it's a loop. It will say while number is less than or equal to 3. So our values right now is what? 2, because we added in this line added 1 into number, so it becomes 2. It will run again, and then it will become 3. Now when it come and run, if the number less than or equal to 3, print. It will still print because it is equal to sign as well, right? It is either less than or equal to, it will still print. And then it number will become 4. Now it will come and say that 4 is not less than or equal to 3 because it is greater than now. 4 has become greater, and then it will come out of this loop. So that's how you basically run in your head as well. So let's try run this program. See, this is the result. Did you understand what I did? You want to try that again? It's easier to understand this way. The number was 1, number value was 1 first time, and it's called iteration when it's run. That's why I was saying iteration 1, number value was 1, print value on equal, then add number, add 1 into number, so it becomes 2. Iteration 2. Now it is running again. So what it is doing, number 2 is less than or equal to 3, which is again not true. So it will run again and again and again until this condition is met. And then iteration 3, which is compare number 3 less than or equal to 3, and then iteration 4, compare number 4 less than. See, that's how it ran. So iteration 1, it ran, it print a value, and it added number and became 2, and it's same way it ran to iteration 2, 3, 4, and out of iteration 4, it it came out of the loop. So this is the basic difference between for loop and a while loop. In for loop, you know how much numbers you need to run something. In while loop, you just know the condition where it needs to come out. You don't know how many time it will run. Okay, if you don't ask any questions, I will not know if you're understanding this or not. If I'm too fast or too slow, please let me know. Okay, so let's move to our next topic. Just we have how much time left? We have 12 minutes. So our next step for today is decision making. Any questions? Um, You have any questions, Zoom? Your mic is on. Okay, session 3. Now we will see if condition. All these things will be used in our next session. That will be a game. So please pay attention to this. Okay, copying this here. If, and you know what? If condition, I would say it's the backbone of programming. I mean, all those things that you see are components of programming, but if condition, you will find so many things because a lot of times computer programs are doing decision making. You see repetitive tasks, you see a lot of things, calculation, but most of the time it's decision making. If this happened to this, if this happened to that, if this happened to this, behind the scenes is a computer program is like a set of instructions that we saw, but inside those set of instructions, if you talk about percentage, the heavy percentage of instructions have if conditions. It is that important. If you ask me, out of if you have typed like 100 lines of code, probably 60 lines will have if conditions. It is that important. So pay special attention to if condition. If condition is used to 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 help computer program make decision based on some condition. Simple. It is very simple if you look at this way, but it may not be as simple because, like I said, it is used so much in computer programming that I believe that it is like 60% of the time you will see in computer programming. Although today we'll just see a small example, but if statement is, I call it the most important part of computer programming. Again, we'll start with our variable. You can call it anything. For the sake of simplicity, I'm calling it number. And integer, as we discussed, integer is a data type. Last class, input is like a user input. I will take a user input. This is also from lab 2. From last time, enter a number. Okay. Enter number. I'm putting a comment here. Let's say check if the number is greater than 5, for example. Or let's say for now, I'll give you another example. So what we have to check, what the computer program have to check. Let's say when I say we, like computer program, if number is greater than these signs, we are used in mathematics and they're used in programming as well. Greater than, less than, equal to. These are called operators, and I will give you a separate slide for these two, and use it so many times that you will remember. So for now, just remember this sign means greater than, means this, the open side means it is referring to this number is greater than the on the whichever on the right side. So if number is greater than 0, number, whichever number is entered by the user is greater than 0, then do what? Print. And this is we did last time how to do print number is a positive number. Okay, let's see. Let's run it. Okay, it is asking here to enter a number, and I say 6. Oh, sorry, I have to add 6 here. Say 6 is a positive number. Okay, let me add a little space here. I say 7. I added a 7 is a positive number. Okay, how about I do some variation here? See? So I say if I say check if the number is greater than 5. So if the number is greater than 5, the print number is greater is greater than 5. Then I can put another if condition. I have to align this and we'll discuss why it is turning red even if I'm typing it correctly. This is our next topic. If number is greater than, if number is less than 5, see less than is opposite of greater than. Less number is less is less than 5, and then we can try if number is see I put instead of 1 I put 3 if conditions. Let's see what happens. So I say 7. The 7 is greater than 5. I run it again. I said 3. So 3 is less than 5. And I said 5. So 5 is equal to 5. See? So this is, we are basically making decision uh, this based on condition. So we are entering a number and we're checking if the number is greater than 5, print this. If its number is less than 5, print this. If number is equal to 5, print this. So even though it looks very simpler, but this is very important, and we will be using this if very often in our whole computer programming going forward. So it is very important that you understand. So the topic that I want to cover quickly uh, is to notice that when I do this here, you see you have a red line here. Why is that? So Python language uses block of code with indentation. You know what indentation is? Indentation is like you arrange your code with or format your code with spaces and tabs properly. And that's how Python understand that this is a block of code that belongs to this. So for example, if I'm typing if and then put a colon here, then it will expect the next line will be a certain tab away from this. And this is called indentation. So if you notice, and then in other languages, they use, for example, I give you examples. This is an example of other language. They use curly brackets, and whatever you do is a body or block of code. But Python uses indentation or tabs to consider a block of code. So if you don't use this indentation properly, it won't understand that if this is part of this if condition or this condition or this instruction at all. So it is important to understand the indentation. And don't worry, you will, if you're not understanding what I'm trying to explain here right now, you will understand it once we start using it more often. Right now, you just remember to use the tab key after in if condition or for loop or while loop. You probably noticed I did that in while loop as well. Whenever you need to specify a body of code or a block of code, you need to use with the tab key on the keyboard. Okay, so and the last piece I want to show is for today's class is functions, which I know we are a little over time here, but let's do it real quick because that's very important. That okay, functions. So for example, they are used. Let's like I gave you example of add. So like for example, I want to add numbers, subtract numbers, or those. So instead of doing it again and again, if you need to do something again and again and again and again, so instead of doing that again and again and again, you just do it once. And just like I gave you the example of program, instead of writing those instruction set, sometimes you have multiple instructions to do a single task inside a program. So inside a program, when you have multiple instructions to do simple tasks, you write down those instructions inside one single block of code and you call it a function. A code block, if you remember Scratch. So basically, function is a code block that you can call it anywhere from. So let's say I give you example, print hello world, right? So what it will do, it will it will simply print hello world, right? That's a simple thing. But whenever you need to do something, whenever you need to print something, or you have to type print. What if you are saying print, and then you have to remember these codes, and then you have to type in this, right? So this is a simple example, but what if you want to make it more simpler, right? So what you could do, you say, how about I create something more simpler? You said define, and define short form is def, and you say greet, and then again you have to use the indentation to show this is the body, and say greet and hello world. See, now you define greet with this instruction. Now, whenever and wherever in your program you call greet, it will do the same thing as this. You don't have to type this command again. Again, you just have to say greet. And greet is easier to remember than print bracket open. And let's say you have more things to add here. How are you doing today? Is is there anything I can see? If you have to type this again and again and again and again, it will be difficult, right? Instead, you define in one big function here, and now whenever you need, you just say greet. And it will do all the things for you. See? You don't have to type this. You type this one time, and now whenever you need to use it again, just greet. So that's why you use functions. So it becomes like reusability. And sometimes you create functions to do calculation, like you are making a calculator, you need to add sometimes. You don't add like again and again. You just create add function, you create subtract function, and you just provide values, and it does thing for you. So you write the code for adding one time, and you can use it again and again and again. So same way, you do these things um, to make your code more cleaner. So that's how the lines of code becomes less, because every time you need to greet, you don't type like one, two, three, four, 5 lines or 4 lines. You just type greet, and you will achieve the same result. So that's where that was our 4 things that we discussed today. So if we do a quick recap, so today we did 4 labs. We discussed for loop, while loop, if condition. We discussed about the indentation and the functions. So let me quickly copy paste this code to you guys so you can try at home. So this is the code for loop, and please play around with this so you'll have more understanding of what we did. So this is for loop. This is we did for while loop. This we did for if condition. Oh, and then lastly, the function. Okay, please try this at home and let me know if you have any questions. Uh, just out of excitement, the next class will be starting to build uh, our first game because that I believe that will make our class more interesting, and we'll start working, developing on these concepts quicker uh, while keeping our interest intact. So we'll be using all these if functions, loops, and variables, all these concepts very much in detail. So it is important that you start revising everything. So next time when we start using them, you won't have any difficulty what they are. And the next game we'll be using uh, one of the Python inbuilt capabilities, libraries that we call libraries, and using those we'll start making smaller uh, games. And there is a chance that I will also ask you to build between now and next Sunday. I'll ask you to build a small, application or program, just a small calculator, or try typing table, the two times table or three times table using for loop, uh, or typing a calculator, a program to write a calculator. If you can, let's see if you can. And then the next session, we'll start our first game. That will be a great way to, continue forward. Uh, so, any question, please let me know. If there are no questions, then we can end our session. Please let me know if you have any questions. It's going once. I see some chats here. All right, so that means that there are no questions so far. Thank you for attending today's session, and I'm really, really, really looking forward for our next session.